The three problems you see right now are your warm-up problems. I want you to pause the video, write down the three problems. I want everybody to try the first one once most or everyone have the first one done. Start the video, see the solution, ask questions to the substitute if you have them, then move on to the second one, and so on. So do them one at a time. Pause the video, try the first one, start the video, watch the solution, and so on. On our first problem, hopefully we recognized that the 8y minus 8y right here cancels out. So I can go ahead and add the equations together. I don't need to multiply the equations by anything. And I get negative 8x equals negative 40. Dividing both sides by negative 8 gives me x equals 5. To get the y value, plug 5 into either equation. I'm going to plug it in right here. So we have negative 3 times 5 plus 8y equals negative 31. Multiply. Add 15 to both sides. I get 8y equals negative 16. Divide by 8. Y equals negative 2. X equals 5, y equals negative 2 is correct. Go ahead, pause the video, and move on to number 2. For our second one, none of the variables cancel out as it's written. If you want to eliminate the x's, you need to multiply the top equation by negative 3. That will work fine. I am going to eliminate the y's by multiplying the second equation by 2. I've got minus 4y. I want this one to be positive 4y. Either way will work great. You should get the same solution no matter which way you do it. Top equation did not change. Bottom equation we multiply by 2. I get 7x equals 49. Divide both sides by 7. This pen is going a little crazy here. X equals 7. Plug 7 in to get y. If I plug 7 in here, it says 7 minus 4y equals 3. Subtract 7 from both sides. Negative 4y equals negative 4. And divide both sides by negative 4. X equals 7, y equals 1. And finally, number 3, 8a plus 6b is 36, 10a plus 8b is 44. Again, you could eliminate either variable. I do think the b's might be a little bit easier. 6 and 8, we can make those both 24. So I'm going to multiply the top equation by 4. And the bottom equation by negative 3. That way this gives me 24b and minus 24b. So 4 times 8a, 6b times 4, and 36 times 4. Negative 3 times 10a, negative 3 times 8b, and negative 3 times 44 gives us negative 132. Adding the equations together, our b's cancel. I'm left with 2a equals 12. Dividing by 2 gives me a equals 6. Plugging 6 back in, I'm going to plug it into the bottom equation. I would have 60 plus 8b equals 44. Subtract 60. Eight b is negative 16. And divide by 8. b equals negative 2. Moving into the notes. Today's notes are on using story problems to set up a system of equations and then solve that system of equations. In your notes, you don't need to write down every word that's up there, but you do need to write the problem down. You shouldn't just have an answer with no problem. That's not going to help you out much. The school that Stefan goes to is selling tickets to a choral performance. Probably not terribly important. Don't need to write that down. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. I would write that down. And then on the second day, the school took in $52 by selling 3 senior citizen tickets and 2 child tickets. So 3 senior citizen tickets, 1 child ticket, $38 total dollars. $52 for 3 senior citizen tickets and 2 child tickets. We are asked to find the price of a senior citizen ticket and the price of a child ticket. So everything that's highlighted should go in your notes there. Whatever we're trying to find, in this case, the price of a senior citizen ticket and the price of a child ticket, those should be our variables. So price of a senior citizen ticket, we're going to call that S. S for senior citizen, price of child ticket, C for child. We need to formulate 2 equations relating C and S. So we know if we purchase 3 senior citizen tickets, 3S, plus 1 child ticket, 1C, that's going to give me a total of $38. There is one of our equations. Hopefully you can come up with the other equation. It is 3S plus 2 child tickets equals $52. We now have a system of equations. We solved that system the same way we solved all the other ones that we've done. This one, it looks like I've got S and C on the same side, so I'm going to use elimination to solve it. 3S and 3S almost cancels out, but they're both positive. So I'm going to multiply this top equation by -1. So that now I have -3S minus 1C is -38. And the bottom equation says 3S plus 2C is 52. Adding my equations together, now these cancel. I get 1C is 14. The price of a child ticket is $14. Child ticket is $14. It also wants to know the price of a senior citizen ticket. So we take 14, we plug it in for C. We can plug it into either equation. I'm going to plug it in right there. It says 3S plus 1 times 14, that's just 14, equals 38. Subtract 14. Three S equals 24. Divide by 3. And a senior citizen ticket costs $8. Make sure you answer the question and ask the price of the senior citizen ticket and the price of a child ticket. This is our answer. Number 2 here says talent show committee sold a total of 530 tickets in advance. Student tickets are $3 each, adults are $4 each. And the total receipts were $1,740. Again, you don't need to write down every word, but you should get enough in there that you can look back on it and use it to study. So sold a total of 530 tickets. Student tickets, $3 each. Adult tickets, $4 each. Total receipts were $1,740. Again, we want to start by defining our variables. We are looking for how many of each type of ticket were sold. So student tickets, let's call that S. And adult tickets, we're going to call that A. We know that a total of 530 tickets were sold. So if I take the number of student tickets that were sold and add it to the number of adult tickets that were sold, we sold a total of 530 total tickets. And then if we look at the total amount of money we brought in, we bring in $3 for every student ticket, plus $4 for every adult ticket. And if I add up all the money we brought in $1,740. There's our system of equations. To solve it, we need to eliminate one of the variables. Neither one's a bad choice. I'm going to eliminate the s's. This is 3s, so I want this to be minus 3s, so I need to multiply by negative 3. Bottom equation did not change. Top equation would be negative 3s minus 3a equals whatever 530 times negative 3 is. This would for sure be a calculator problem. Negative 1590. Add your equations together. And we found that each adult ticket, there were 150 of them. Adult tickets, 150. And now we need to find how many student tickets we sold. Plug 150 in for A. We have S plus 150 equals 530. And solve for S. And I find that there were a total of 380 student tickets sold. 150 adult tickets, 380 student tickets. We're going to try one more problem like this. This one tells us that Jerome is 18 years younger than Andrew, and the sum of their ages is 126. We need Andrew's age. So Jerome's age, let's call that J. Andrew's age is A. We know Jerome is 18 years younger than Andrew. So if I take Andrew's age, Jerome is equal to 18 years younger than Andrew. So Andrew's age minus 18 would be equal to Jerome's age. It also tells us the sum of their ages is 126. Sum means add. So if I add their ages together, I get 126. And we have our system of equations set up. Because one of the equations says J equals, substitution is going to be your best method here. We're going to take A minus 18 and substitute it in for J. So it's going to say A minus 18, I put that in for J, plus A equals 126. Combine like terms, A plus A is 2A. Add 18. 2A equals 144. Divide both sides by 2. And I get A equals 72. A is 72. A is Andrew. So Andrew is 72 years old. That's all it asked. What is Andrew's age? We found it. If it wanted both of their ages, you would take 72 and plug it back in right here for A. That is all for today's notes. Reach out if you're having any questions.